Welcome to Two Projects. In this video, we are going to explain the project EATN, an efficient adaptive transfer network for aspect level sentiment analysis. Introduction. Sentiment analysis plays a crucial role in understanding people's opinions and attitudes towards products, services, or topics. Traditional sentiment analysis techniques often provide a generalized sentiment for entire sentences or documents, overlooking the nuanced sentiments associated with specific aspects or entities mentioned within the text. So, this project delves into aspect level sentiment analysis, a specialized branch of sentiment classification. Unlike traditional sentiment analysis, which assigns a single sentiment to an entire text, aspect level sentiment analysis aims to identify the sentiment polarity, that is, positive, negative, or neutral, of individual aspects or entities mentioned within the text. So, aspect level sentiment analysis finds applications in various domains such as customer feedback analysis, product reviews, social media monitoring, and market research. By accurately identifying the sentiment towards specific aspects, businesses can gain deeper insights into customer preferences, strengths, and weaknesses of products or services. Despite its importance, aspect level sentiment analysis poses several challenges. These include the need to handle domain specific language, account for context dependent sentiment, deal with ambiguous expressions, and ensure robustness across diverse datasets and domains. So, in this project, we propose a novel method named Efficient Adaptive Transfer Network, that is EATN, to address the challenges associated with aspect level sentiment analysis. EATN incorporates multiple modules, including a domain adaptation module, a MKMMD based MLP, and an aspect oriented multi head attention mechanism. To effectively handle domain adaptation, feature transferability, and aspect context association, ultimately improving classification performance and adaptation efficiency. And through extensive experiments on real world datasets, we demonstrate the effectiveness of our proposed approach in achieving state of the art results in aspect level sentiment analysis. Objective of the project. So, as I already mentioned, the primary objective is to create a system that can analyze sentiments at a granular level, specifically targeting individual aspects or entities mentioned within text, rather than providing a generalized sentiment for entire documents or sentences. This ensures a deeper understanding of opinions and attitudes towards specific aspects of products, services, or topics mentioned in the text. So, domain adaptation challenges refer to the need for a sentiment analysis system to perform effectively across diverse domains such as different industries or topics. So, the objective involves developing mechanisms within the system to adapt and perform well in various domains, ensuring its robustness and applicability in different contexts. And sentiment analysis systems often struggle with capturing nuanced relationships between aspects and their context within text. So, the objective also focuses on improving accuracy by developing methods to effectively capture and analyze these relationships. By understanding how aspects are mentioned and perceived within different contexts, the system can provide more accurate sentiment analysis results. And the goal involves comparing the developed sentiment analysis system, that is EATN, against existing models such as LSTM, TD-LSTM, MEMNet, ATAE-LSTM, MGNet, IAN, TNet, and BERT. Comparative analysis allows for assessing the effectiveness, efficiency, and performance of the proposed systems in relation to established methods. It provides insights into the strengths and weaknesses of the proposed approach and helps identify areas for improvement. So, requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working models of law of work. So the first step is importing required packages. In this step, we import essential libraries such as NumPy, Pandas, sklearn, Matplotlib, TensorFlow, Keras, and NLTK. These packages provide functionalities for data manipulation, machine learning algorithms, visualization, and natural language processing tasks. The second step is exploring the dataset. So here the dataset consisting of reviews from restaurants and laptops and also data from Twitter is explored to understand its structure, features and distribution of sentiment polarities. This exploration aids in identifying potential patterns and trends within the data. The third step is visualization. In this step, a polarity count graph is generated to visually represent the distribution of sentiment polarities in the dataset. This visualization provides insights into the overall sentiment distribution, helping in understanding the sentiment tendencies of the reviews. The next step is data processing. So, the dataset undergoes several pre processing steps, including the removal of URLs and special characters, punctuation removal, elimination of stop words, and normalization of the text data. These steps are essential for cleaning and standardizing the text data before further analysis. The next step is tokenization. In this step, the text data is tokenized using different techniques such as count vectorizer, Keras tokenizer, and BERT tokenizer. Tokenization converts the text data into a format suitable for machine learning algorithms by breaking it down into smaller units such as words or subwords. The next one is feature selection. So here, feature selection methods are applied to select the most relevant features from the tokenized data. This step helps in reducing dimensionality and focusing on the most informative features for sentiment analysis. The next step is train and test split. In this step, the dataset is split into training and testing sets to evaluate the performance of the models. The training set is used to train the models while the testing set is used to evaluate their performance on unseen data. The next one is training and building the model. So here various machine learning models and deep learning models including long short-term memory, target dependent long short-term memory network, aspect term attention LSTM, multi-grain network, interactive attention network, transformation network, bidirectional encoder representations from transformers and the proposed EATN, that is efficient adaptive transfer network, are trained and built using the pre-processed data. These models learn from the training data to predict sentiment polarities accurately. And in the next step, as an extension to the project, hybrid models such as LSTM combined with GRU and BERT combined with CNN LSTM are employed to enhance the robustness and accuracy of the final predictions. Additionally, a Flask framework with SQLite for user authentication is built. So after signing in, users can input text. So this undergoes pre-processing similar to the training data, ensuring consistency. So the trained model is then used to predict sentiment based on the user's input, providing real-time insights. And latent dirichlet allocation, that is LDA, is applied for topic modeling, revealing underlying themes and topics within the dataset. And the final sentiment analysis results, topic modeling insights, and model predictions are displayed through the front end interface. Now we'll understand about the algorithms used. So the first algorithm built is long short-term memory, that is LSTM. It is a type of recurrent neural network architecture designed to overcome the vanishing gradient problem in traditional RNNs, enabling better long-term dependency modeling. LSTMs utilize gated units to regulate the flow of information, allowing them to capture sequential patterns effectively. So, it is suitable for this sentiment analysis project due to its ability to analyze text data with sequential dependencies and capture nuanced sentiment expressions. The next algorithm built is TDLSTM, that is target dependent long short term memory. So, it is a neural network model specifically designed for sentiment analysis tasks. It incorporates two separate LSTM layers to capture the left and right context of the target aspect or entity within a sentence. By considering the target dependent context, TD-LSTM effectively captures the nuanced sentiment expressed towards specific aspects, making it suitable for aspect level sentiment analysis in this project. The next one is MemNet or memory network. It is a deep learning architecture designed for tasks involving long term memory processing. It works by storing information from input sequences in memory slots and dynamically updating these slots during processing. Memory network is suitable for this sentiment analysis project as it can effectively capture and retain contextual information over extended sequences, enabling accurate sentiment analysis with a focus on aspect level understanding. The next algorithm built is ATAE LSTM, that is attention based target dependent LSTM. It is a sentiment analysis model that incorporates attention mechanisms to focus on target dependent sentiment extraction. It dynamically adjusts attention weights to capture the relevance of words to specific aspects within sentences. This model is suitable for the project as it effectively captures the sentiment expressed towards different aspects within text, enhancing the system's aspect level sentiment analysis capabilities. The next algorithm built is MGNet, that is multi-granularity network. It is a sentiment analysis model that utilizes fine-grained attention mechanisms to capture intricate relationships between aspects and their context in text. By incorporating multi-hop attention on word embeddings, MGNet effectively learns the importance of individual words in conveying sentiment towards specific aspects, making it suitable for aspect level sentiment analysis tasks. So the next algorithm built is IAN, that is Interactive Attention Network. It is a model designed to jointly learn the interaction between aspects and sentences in sentiment analysis. It employs attention mechanisms to dynamically highlight relevant words and phrases in both aspects and sentences, allowing for a fine grained understanding of sentiment. IAN is suitable for this project due to its capability to capture aspect sentence interactions effectively, contributing to accurate aspect level sentiment analysis. The next one is TNet, or Target Specific Sentiment Analysis Network. It utilizes a convolutional neural network layer to extract salient features from text, focusing on specific targets or aspects within sentences. It then employs a component to generate target specific representations of words, enhancing sentiment analysis accuracy by capturing nuanced aspect level sentiments. This model is suitable for the project as it effectively captures context target relationships crucial for aspect level sentiment analysis. The next algorithm built is BERT, that is bidirectional encoder representations from transformers. So it is a state of the art natural language processing model developed by Google. It works by pre training a deep bidirectional transfer model on large corpora of text, enabling it to capture complex language patterns. BERT excels in this project for its ability to understand context and semantics, essential for aspect level sentiment analysis, providing more accurate and nuanced sentiment predictions. And the next one is EATN, that is Efficient Adaptive Transfer Network. It integrates three key components: embedding module, aspect oriented multi head attention module, and domain adaptation module. It captures semantic relationships between aspects and contextual words comprehensively, enhancing aspect level sentiment analysis. EATN's adaptability across domains and ability to capture nuanced aspect context relationships make it ideal for the project's focus on robust sentiment analysis. Now we'll see the comparison graphs of the algorithms built using laptop dataset. So this is the horizontal bar graph comparing accuracy scores of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. Accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. These are the comparison graphs of the algorithms built using restaurant dataset. Similarly, these are the comparison graphs of the algorithms built using Twitter dataset. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is archive folder in which I have required restaurant, laptop and Twitter dataset on which we'll train the models. This is static folder. This folder consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are all the model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And these are Jupyter source files which contain a combination of code, graphs, and outputs all in one place. So Jupyter source file allows users to write and execute code in individual cells, making it a popular choice for data science. This is topic modeling Python main code file, and this is signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file Explorer. I'm copying it. Open Anukunda prompt. So now use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first, fill in all these details and click on register buttons to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide a credentials, username and password to sign in. I'm giving mine and click on login button. So it has redirected us to the prediction page. So here we can see a prediction link, click on it. So as I mentioned earlier, we can execute this project using three different datasets: laptop, restaurants, and Twitter. So first we'll execute it using laptop dataset, click on it. So here we can see a enter your message box where we have to enter a text and the application will classify the sentiment of the text. So now we'll enter a text. So I have entered this message. Now click on predict button. It will take some time to load. So this is the given message and here we can see the result, that is the review is negative. And here we can see the words dependent upon which the application has classified this message as a negative review. We'll try again. Click on prediction link, click on laptop link. We'll try giving another message. This time I have entered this message. Now click on predict button. This is the entered message and here we can see the classification, that is the review is positive. So dependent upon these words, the application has classified this message as a positive review. Now we'll execute the project using restaurants dataset. Click on restaurants link. We have to enter a message here. So this is the given text. Now click on predict button. So this is the entered text, and here we can see the label, that is the review is neutral. So the application has classified this message as a neutral review, and here we can see the words dependent upon which the application has classified this message as a neutral message. We'll try again. Click on prediction link. Click on restaurants link. We'll try giving another message. I have entered this message. Now click on predict button. This is the given message, and here we can see the classification, that is the review is positive. And dependent upon these words, the application has classified this message as a positive message. Now we'll execute the project using Twitter dataset. Click on Twitter link. We have to enter the message here. This is the message I have entered. Now click on predict button. This is the message, and here we can see the label, that is the review is classified as neutral. And dependent upon these words, the application has classified this message as neutral. So similarly, we can upload any message and can get the sentiments as positive, neutral, or negative. Now click on sign out. So the conclusion here is the project introduces a novel approach to aspect level sentiment analysis through the development and evaluation of the efficient adaptive transfer network, that is EATN, which addresses critical challenges in sentiment classification. Through extensive experimentation and comparative analysis against established models such as LSTM, TD-LSTM, MEMNet, ATAE-LSTM, MGNet, etc., the effectiveness and performance of EATN are thoroughly evaluated. The project extends its scope by deploying LSTM plus GRU, that is combination of LSTM and GRU, a hybrid model that outperformed all other models across various datasets and performance metrics. This extension enhances the robustness and accuracy of sentiment analysis predictions. And the integration of a Flask-based front-end application provides users with a seamless and intuitive interface for real-time sentiment analysis, offering insights into sentiment classifications and topic modeling results generated using latent dirichlet allocation, that is LDA. And the project lays the groundwork for future research and development in sentiment analysis, highlighting the potential for further enhancements, extensions, and applications in areas such as customer feedback analysis, product reviews, social media monitoring, and market research.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.